us look into how we have to design a PDA. So PDA is usually accepted by context-free grammar or context-free language. So we usually design PDAs for the languages that are context-free. So for those languages, we will be designing a PDA. I have taken one such example. Design PDA for the language L is equal to A power n B power n such that n greater than equal to 1, and show the ID instantaneous description for the string AABB. So this is what the question is. So we have to design PDA for this language. So when you see the language A power n, B power n, so what do you understand is, first we need to have set of A's and then followed by B's. So we can have strings like AAA, BBB, and the number of A's should be equal to the number of B's. Now comes the importance of stack. So why do we have to use stack here? Because I need to know how many A's I have received, and for the corresponding B's I have to count it. So only we have a stack element. So by taking this example, I will tell you how stack works. So as we all know, so stack element is Z0. So whenever you receive a A and top stack element is Z0, A will be pushed onto the stack. A will be pushed onto the stack because we need to know how many A's we have received from the string. So the second A is the input symbol, this is the input symbol, this is the your top stack element A. So when you receive a A and you see A in the stack, again push that A to the stack. Again push that A to the stack. Again you will have one more A, push that as well to the stack. Push that as well to the stack. Now you start reading B. So when you start reading B, you understand that there are no more A's because it has to be A followed by B. So after receiving B, you should not receive any A's. So when you see a B, you should start popping the A's. So when you receive the first B, you will start pop this A, saying that one B is received and one A is popped out. So there's one more B, you will pop out one more A, and there's one more B, you will pop out one more A. And when you reach the end of the string, that is epsilon, when you reach end of the string is represented using epsilon. When you reach this epsilon and the top stack element is Z0, you can say that there are no more extra A's or extra B's. So this can be accepted by the PDA. This can be accepted by the PDA. So this is how actual PDA will work by using the stack. So we will see how to design PDA for the set string AA, BB or AAA, BBB. So first of all, let me start with state Q0. So my initial state is marked using arrow mark. So Q0, I am starting with the initial state. So here when I receive AABB as the string, when I see A, what will be in the stack? Stack will contain Z0. So stack will contain Z0. So when you read A corresponding to the stack symbol Z0, you need to push A to the stack. You need to push A to the stack. So you need to write the transition here. So how will you write the transition here? I will let you know. So here you will write the input symbol, and you will have the stack symbol, and you will either push or do a pop operation. This is how you write the transitions in the transition diagram. So first is the input symbol, next is the stack symbol, and next is the push or pop element. So if you are pushing, you will write the transition as your current stack element is Z0 and whatever you are pushing, that is E. So that is the push operation. So if you want to pop, then you will use an epsilon. If you want to pop an element from the stack, you will use epsilon. So now we will write the transition here. So Q naught upon reading A as the input symbol. So A as the input symbol, and what should be there in the stack? Z naught. So Z naught will be there in the stack, and what do? Push or pop. So we need to push this A to the stack. So we will write that as A Z naught. So this is the current stack element which is already there in the stack, that is Z naught, and A is the new input symbol that is added to the stack. So this is what is push operation. So again, after reading one A, you are reading one more A, and what is there in the stack? Mention that. So here A is on the stack. What do? You again push A's. So how many ever A's you read, you need to push it into the stack. So you will push that A to the stack. You will push that A to the stack. So what will you do? A is the current stack symbol, and A should be pushed to the stack. So this is how you represent A. Now you start reading B. Now you start reading B. When you read B, what should you do? You have to start popping. You have to start popping. So can I write it in the same state? No. If I write it in the same state, if I write that transition in the same state, what will happen is I can receive A's after B. So that should not be the case. So your AB, this is not accepted by this language, A power n, B power n. So what is this AB? So we are reading A, popping for B, again you are reading A. So that should not be possible, means you need to change the state. You need to change the state from Q0 to Q1 when you start reading B. So when you start reading B, B is the input symbol. What is there on the stack? Stack contains A, and what do? You start popping it. So pop is represented using epsilon. So you will write epsilon. So you are reading B, and top stack element is A, and then when you read B upon A, then you have to pop it. So pop is mentioned using epsilon. So this is only for one B. Again you are reading one more B. So this one more B, where should it go? Again you will have a self loop in Q1. You will have a self loop in Q1 saying B will be the input symbol, A will be the stack element, and you will perform pop operation. Next, so you are reading B, you are popping this A. Next, what do you read? You read an epsilon, because you have reached end of the string. You have reached end of the string. So when you read epsilon, what should be in the stack? Z naught. Z naught should be in the stack. So when you read epsilon and stack contains Z naught, keep Z naught as it is. Keep Z naught as it is and reach final state Q2. And reach final state Q2. So epsilon is the input symbol and Z naught is the top stack element. You reach the final state because the string can belong to the language A power n, B power n. So this method of writing the final transition is known as accepting PDA acceptance by final state method. Final state method. So in the question, if they have asked you design the PDA using for the language by accepting using final state method, then you have to write this. Or else there is one more method which is empty stack method. Empty stack method. So if you have to use empty stack method, then there is one more representation for this which says epsilon is the input symbol, Z naught is the top stack element. What do? You pop that bottom of the stack. Means you empty the stack. You empty the stack by removing this element from the stack. So this is nothing but empty stack method. This is nothing but empty stack method, and this keeping your Z0 in this and reaching the final state is nothing but final state method. That is nothing but final state method. I hope this is understood. So, here we have designed the PDA for the language L is equal to a power n b power n such that n greater than equal to 1. So, we will see few examples. So, by looking at this PDA, we will see how to write the transition function. So, this is a transition diagram. This is nothing but the transition diagram. So, we will see how to write the transition function for the same. So, for this, if you want to write the transition function, it is like this. So, Q naught current state comma the input symbol and your stack symbol, top stack element, your transition function, your current state, whichever state you are in present in, your input symbol, your stack top element, and you go where for the next state and you either push or pop. So, you have to write the transition function like this. So, you have to mention the current state, the input symbol you are reading and what is on the stack and to which state do you go, and push or pop operation. You need to mention this in your transition function. So, we will see how to write transition function for this already designed PDA. So, delta Q naught is the current state, your input symbol is A, we are writing the transition function for this, your input symbol is A and Z naught is the top stack element. So, what do? There is a self loop here. So, you go to the same state, that is Q naught, and what do? You do a push operation, that is A Z naught. So, A Z naught will be pushed to the stack. So, this is how you write the transition function. So, Q naught is the current state you are in, A is the input symbol you are reading and Z naught is the stack symbol that is present in the stack. And where do you go? There is a self loop here. So, you stay in Q naught and A Z naught is the push operation, you perform. So, we will write the transition function for other transitions as well. So, delta, again you are in the state Q naught. So, we are writing the transition function for this one. So, A is the input symbol, again A is in the stack. So, Q naught A. So, you stay in the same state Q naught and you perform a push operation A. So, that is what you have mentioned in the transition function as well. So, what is the next transition function? BA epsilon. So, this we will write. So, we will write the transition function for BA epsilon. So, delta Q naught is the current state you are in. What is the input symbol you are reading? B is the input symbol and A is on the stack. So, what do? You perform a pop operation and go to state Q1. So, that you have to mention. So, go to state Q1 and perform a pop operation, that is epsilon. So, next you are in Q1 now, we are writing this transition B comma A epsilon. So, B is the input symbol, A is the stack element and what do? You perform a pop operation. So, next transition is for this one Q1. You are in state Q1, reading epsilon and stack element is Z naught. What do? Q2, you go to the state Q2 and you keep Z naught as it is. you keep Z0 as it is. That is known as final state method. Accepting by final state method, or else you can even write it as delta Q1 upon epsilon and Z0. What do? You can write this transition as well, mentioned if it is mentioned in this question, accept it using empty stack method, do it using this transition function, or else do it using final state method. You can do it anyways. So, Q2 comma epsilon, you are emptying the stack. So, this is nothing but accepting by empty stack method. So, this is the transition function for the PDA which we have designed for the language a power n, b power n such that n is greater than equal to 1. So, in the question it even mentioned write the instantaneous description for AABB. So, we will see how to write the instantaneous description for AABB. So, now we shall write the ID for the string, that is the instantaneous description for the string AABB. So, how to write it? So, we know how it works, correct? We have seen an example of taking a stack and how it works. So, we will show that in the instantaneous description. So, how to write that? So, here we will have the start state, that is Q0, and your input string, that is AABB, and what is there in the stack? Stack initially will be empty, and empty stack is represented using Z0. So, we will see how we will write the transition for the instantaneous description for the string AABB. So, Q0 is reading A and the top stack element is Z0. So, what is the transition which we follow? So, which is this one, A Z0, A Z0, you are pushing A to the stack. So, that is what we have to do. You are in the same state Q0, so you are not changing the state, you are in the same state Q0. So, stay in the same state. The remaining string is ABB, write down the remaining string ABB, and you are pushing A to the stack based on this transition. So, push that into the stack. So, in your stack you will have A and Z0. Next, for the next you are representing using this symbol. So, Q0 is reading A again. So, Q0 is reading A again with A as the input symbol, stack symbol. So, this is the transition which you have to follow. So, you will stay in the same state Q0 and the remaining string is BB. So, write it BB and you push this A to the stack. So, mention AA Z0. AA Z0. Next, so you have Q0. So, next we will be having Q0 is reading B and A is in the stack. So, Q0 is reading B and A is in the stack. So, what do? You need to pop and change the state to Q1. So, we will be changing the state to Q1 and the remaining string is B, and what do? You pop A from the stack. So, remaining is A Z0. So, next Q1 is reading B and A is again in the stack. So, which represents this particular transition. So, we will stay in the same state Q1 and B we have already read. What is the remaining string? Epsilon. And what do for this A? We will pop it out. So, that is Z0. So, next what do? Q1 is reading epsilon and top stack element is Z0. So, what do? Using this corresponding transition, we will go to state Q2 and epsilon is the remaining string itself and keep the Z0 as it is for final state method. So if it is not final state method, if it is empty stack method, then you would have performed Q2 comma epsilon epsilon, Q2 comma epsilon epsilon, which is empty stack method. So whatever you mention here, so if you mention this one, you need to write this transition. If you mention this empty stack method, if you use empty stack method, you need to mention this in the transition when you are writing the instantaneous description, So we have seen how to write the PDA, the transition diagram as well as the transition function, and after writing both transition diagram and transition function, you need to write the instantaneous description for the given string like this. So this is the way to write the instantaneous description for the given string, that is AABB. If there was a string which is AABBA, so should this be accepted? No, this should not be accepted. We will see with an example how it works. So Z0, you are reading A, I am just taking an example which does not belong to the language, should not be accepted by the PDA. So you are reading A and Z0 is the top stack element. So what happens? You are pushing this A to the stack. Again you are reading one more A, again you need to push A to the stack. You are still in the same state Q0. When you read B, you will start popping and you will go to state Q1. So again when you read B, you are in the same state Q1 and will pop A. Now you are reading A and stack symbol is Z0, but you are in the state Q1, there is no transition for it. There is no transition for this particular input symbol and stack symbol from state Q1. So you are stuck in state Q1 itself, you have not reached the final state. So PDA does not accept this kind of strings. So this is just an example of rejecting a string from PDA, because you have not reached final state, you are in state Q1 itself. Q1 is not a final state, so it is rejected.